Welcome to our comprehensive guide on heat for ICSE Class 10. In this video, we'll explore the fundamental concepts of heat, its effects, and its applications in daily life. Understanding heat is crucial as it forms the basis of many scientific phenomena and practical applications. We'll start by defining what heat is, how it differs from temperature, and why this topic is so important in both science and our everyday experiences. So let's dive in and unravel the mysteries of heat together, setting the stage for a deeper understanding in the coming scenes. Heat is a form of energy that transfers from one body to another due to a difference in temperature. It always flows from a hotter object to a colder one until both reach the same temperature. This transfer of energy can happen in various ways, which we'll discuss in detail later. For now, remember that heat is not a substance, but rather a process of energy movement. This distinction is key to understanding many thermal phenomena you encounter in your studies and daily life. It's common to confuse heat with temperature, but they are not the same. Temperature measures how hot or cold an object is, while heat refers to the energy transferred due to temperature difference. For example, a cup of hot tea and a bathtub of lukewarm water may have different temperatures, but the bathtub can contain more heat energy because of its larger mass. Understanding this difference helps in solving many problems related to heat in physics. Heat is measured in joules J in the SI system, but you may also encounter calories cal in some contexts. 1 calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. In most scientific calculations, joules are preferred, but understanding both units is important for solving various problems and interpreting data in your textbooks. To measure heat, we often use a device called a calorimeter. This instrument helps us determine the amount of heat exchanged during a physical or chemical process. By carefully observing temperature changes and knowing the mass and specific heat capacity of substances involved, we can calculate the heat transferred. This method is widely used in laboratories and forms the basis of many experiments in your curriculum. Specific heat capacity is a property that tells us how much heat is needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Different materials have different specific heat capacities, which explains why some objects heat up faster than others. For example, water has a high specific heat capacity, making it slow to heat or cool, which is why it's used in cooling systems. Conduction is the process by which heat flows through a solid material from the hotter end to the colder end. Metals are good conductors of heat, which is why cooking utensils are often made of metal. In contrast, materials like wood and plastic are poor conductors, making them good insulators. Understanding conduction helps explain everyday phenomena, like why a metal spoon feels cold at first but warms up in hot soup. Convection is the transfer of heat in fluids, liquids, and gases through the movement of particles. When a fluid is heated, it becomes less dense and rises, while cooler, denser fluid sinks. This creates a convection current, which helps distribute heat. Examples include boiling water and atmospheric circulation. Convection is essential in many natural and engineered systems. Radiation is the transfer of heat through electromagnetic waves without the need for a medium. The sun's heat reaches Earth by radiation, traveling through the vacuum of space. All objects emit some thermal radiation, but hotter objects emit more. This process is crucial in understanding how energy moves in the universe and affects our daily lives. Materials can be classified as conductors or insulators based on how easily they allow heat to pass through. Conductors, like metals, transfer heat efficiently, while insulators, such as wood, rubber, or plastic, resist heat flow. This property is used in designing everyday objects, from cooking utensils to building insulation, to control heat transfer for comfort and safety. When substances are heated, they generally expand. This phenomenon is known as thermal expansion. It occurs because particles move faster and spread apart as temperature increases. Thermal expansion has practical implications such as gaps in railway tracks and expansion joints in bridges, which prevent damage due to temperature changes. Thermal expansion is used in many practical applications. For example, the metal lid of a glass jar can be loosened by running it under hot water, causing the lid to expand. Similarly, bimetallic strips and thermostats use different expansion rates of metals to control electrical circuits. These examples show how understanding heat can solve everyday problems. Heat plays a crucial role in changing the state of matter. When a solid is heated, it can melt into a liquid, and further heating can turn the liquid into a gas. These changes, melting, boiling, and evaporation, are all driven by heat energy. The reverse processes like condensation and freezing involve the removal of heat. Latent heat is the energy absorbed or released during a change of state without changing temperature. For example, when ice melts at 0 degrees C, it absorbs heat but remains at the same temperature until all the ice has melted. This concept is important in understanding how substances transition between solid, liquid, and gas phases. Latent heat of fusion is the amount of heat required to change a unit mass of a solid into a liquid at its melting point, without changing its temperature. For water, this value is 334 kJ/kg. This property is essential in understanding processes like melting ice and designing systems for temperature control. Latent heat of vaporization is the heat required to convert a unit mass of liquid into vapor at its boiling point, without temperature change. For water, this is 2260 kJ/kg. This concept explains why sweating cools the body. Heat is absorbed from the skin to evaporate sweat, lowering body temperature. Evaporation is a surface phenomenon where molecules at the surface of a liquid gain enough energy to escape into the air as vapor. This process absorbs heat from the surroundings, causing cooling. That's why we feel cool when sweat evaporates from our skin or when water is sprinkled on floors in summer. Several factors influence the rate of evaporation, including temperature, surface area, humidity, and wind speed. Higher temperatures and larger surface areas increase evaporation, while high humidity slows it down. Wind helps remove vapor, speeding up the process. Understanding these factors helps explain everyday observations like why clothes dry faster on a windy day. Boiling and evaporation are both processes where a liquid turns into a gas, but they differ in important ways. Boiling occurs throughout the liquid at a specific temperature, while evaporation happens only at the surface and at any temperature. Boiling is a rapid process, while evaporation is usually slow and gradual. Cooling by evaporation is a natural process that helps regulate temperature in living beings and the environment. When a liquid evaporates, it absorbs heat from its surroundings, leading to a drop in temperature. This principle is used in cooling towers, earthen pots, and even in our own bodies through sweating. Heat plays a significant role in shaping weather patterns. The sun heats the earth unevenly, causing air to move and create wind, clouds, and precipitation. Understanding how heat influences weather helps us predict changes and prepare for different conditions, making it an essential part of environmental science. We encounter heat in countless ways every day, from cooking food and warming our homes to using electrical appliances. Recognizing how heat is generated, transferred, and managed helps us use energy more efficiently and safely. This practical knowledge is valuable not just for exams but for life. Human body maintains a constant temperature through processes involving heat production and loss. Metabolic activities generate heat, while sweating and blood circulation help regulate body temperature. Understanding these processes is important for health and explains why we feel hot or cold in different environments. Insulation is used to reduce unwanted heat transfer. In buildings, materials like glass wool, foam, and double-glazed windows help keep interiors warm in winter and cool in summer. Proper insulation saves energy and improves comfort, making it a key concept in both science and engineering. Thermometers are devices used to measure temperature. They work on the principle of thermal expansion, where a liquid like mercury or alcohol expands with heat. Digital thermometers use electronic sensors for quick and accurate readings. Knowing how to use and read thermometers is essential in science and medicine. Heat engines are devices that convert heat energy into mechanical work. Examples include car engines and steam turbines. These machines operate by exploiting temperature differences, turning thermal energy into motion. Understanding heat engines is fundamental to studying how energy powers our modern world. Refrigerators work by removing heat from their interiors and releasing it outside. This process uses a refrigerant that absorbs heat as it evaporates and releases it as it condenses. The principles of heat transfer and phase change are at the heart of refrigeration technology. The greenhouse effect is a natural process where certain gases in the Earth's atmosphere trap heat, keeping the planet warm enough to support life. However, increased greenhouse gases from human activities are causing global warming. Understanding this effect is crucial for addressing climate change. Conserving energy involves using heat efficiently and minimizing waste. Simple actions like insulating homes, using energy-efficient appliances, and turning off unused devices help save energy. These practices not only reduce costs but also protect the environment by lowering greenhouse gas emissions. Renewable energy sources like solar and geothermal power harness heat from the sun and the earth. Solar panels convert sunlight into electricity, while geothermal plants use heat from underground. These technologies are vital for a sustainable future and reducing reliance on fossil fuels. Industries use heat in processes like smelting metals, manufacturing glass, and producing chemicals. Controlling heat precisely is essential for quality and safety. Engineers design systems to manage heat flow, ensuring efficient production and minimizing energy waste. Heat affects agriculture by influencing plant growth, soil temperature, and water evaporation. Farmers use greenhouses to trap heat and extend growing seasons. Understanding heat helps improve crop yields and adapt to changing climates, making it vital for food security. Heat drives the water cycle by causing evaporation from oceans, lakes, and rivers. Water vapor rises, cools, and condenses to form clouds, eventually returning as precipitation. This cycle is essential for life on Earth and is powered by the sun's heat. Ecosystems depend on heat for survival. Temperature affects animal behavior, plant growth, and the distribution of species. Extreme heat or cold can disrupt ecosystems, leading to changes in biodiversity. Studying heat helps us understand and protect natural habitats. Modern technology relies on controlling heat. Computers, smartphones, and other devices generate heat during operation. Cooling systems like fans and heat sinks are used to prevent overheating and ensure reliable performance. Managing heat is a key challenge in electronics design. Safety measures are important when dealing with heat. Protective clothing, insulation, and safety protocols help prevent burns and accidents in homes, laboratories, and industries. Understanding the risks and proper handling of heat sources is essential for everyone. Fire is a rapid chemical reaction that releases heat and light. It requires fuel, oxygen, and heat to start and sustain. Understanding how heat contributes to fire helps us prevent and control fires, making fire safety an important aspect of daily life and science education. Cooking is a practical application of heat. Different cooking methods, boiling, frying, baking, use heat transfer to prepare food. Understanding how heat affects food helps us cook safely and efficiently, ensuring meals are both tasty and nutritious. Heat is used in medicine for treatments like hot packs, sterilization, and physical therapy. Controlled application of heat can relieve pain, improve blood flow, and kill harmful microbes. Medical professionals rely on a deep understanding of heat for patient care. Athletes use heat in various ways, from warming up muscles before exercise to using hot or cold packs for recovery. Proper temperature regulation helps prevent injuries and improves performance. Coaches and trainers apply these principles to keep athletes healthy and competitive. Heat is managed in transportation systems, from car engines to airplane cabins. Cooling systems prevent overheating, while heating systems ensure comfort in cold weather. Engineers design vehicles to handle heat efficiently, ensuring safety and reliability on the road and in the air. Spacecraft must withstand extreme temperatures, from the cold of space to the heat of re-entry. Engineers use special materials and insulation to protect astronauts and equipment. Understanding heat transfer is vital for the success of space missions and the safety of crews. Artists use heat in processes like pottery, glassblowing, and metalworking. Controlling temperature is essential for shaping materials and creating beautiful works of art. This intersection of science and creativity shows how heat influences culture and craftsmanship. Human activities that produce excess heat can impact the environment, leading to urban heat islands and affecting local climates. Reducing waste heat and using green technologies help minimize these effects, making our cities more livable and sustainable. This video, we've explored the concept of heat, its methods of transfer, and its wide-ranging applications in science, technology, and daily life. From understanding basic principles to seeing their impact on the environment and society, heat remains a central topic in physics. Keep exploring, stay curious, and remember that the science of heat is all around you, shaping the world in countless ways.